This conference will now be recorded.
Hello everyone, good evening.
Good evening, sir. Good evening.
Um,
Good evening, sir.
let's wait for a couple of minutes, then we'll start. All right, let's start with the class. Let me share my screen. Let me know once my screen is visible.
Yes, visible.
Yes, sir, it's visible.
All right. So uh, we are going to start with update statement. So yesterday we learned how to perform insert statement and delete statement, and now today we are going to learn about update statement. Okay. First, let's see what is there in first table. Now, first table. Okay, let me create it. Okay, so I have these values in first. Okay, so let me show you the structure of first table. So this is first table column structure. Okay, and I have these many columns. These many records in first table. Now let's say I want to perform some update operation. What kind of update operation? Let's say instead of Suraj, I want to change the name of Suraj to Suraj let's say Suraj Singh. Okay, so what I need to update, which column? Name column. Which row? Where row ID is 3, right? What is the table? Table is first table. So I'll write update first table, set the column name. The column name would be name. Name I want to update from this to what? Let's say Suraj Singh. What is the spelling of Singh?
SINGH.
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 It's
S
not
I.
SHIG. Yeah, right.
Let's say I want to change the name of Suraj to Suraj Singh. So how I can identify this row with this ID? So where ID equals to 3. So here is the syntax. Update table name, set name as the new name where ID equals to 3. So using this, I'm identifying this row, and using this, I'm identifying this column, right? So here I'm getting this value and I'm updating it to Suraj Singh. So let's execute. One row affected. Let's see that. So the value got updated to Suraj Singh. Now let's say I want to update the age of Rohit to 40, okay, or let's say 30. So how I can update the age of Rohit to 30? Can you guys please
Set
tell me
age.
the
Yeah,
Update
set
first
age
make table
update?
set age equal to 30 where ID is 7.
7.
Where name is Rohit.
So name is Rohit is also possible, but this is not a unique ID, right? So there could be another person with the name of Rohit.
Yeah,
We need
yeah.
to filter with the unique column so that we can get a unique row, right? So set age equals to 30 where ID equals to 7. See, the age got updated to 30. So is it clear about update statement? Any
Yes, sir.
questions?
Oh, yes. Yeah, if I want to update some column in this table, first table, so how can we add that?
What you want to update?
Just like column name, just like ID, name, age, and mobile number or phone number.
That is
One
not
more
update
column.
statement. Update statement is about updating the data within the table. If you want to update the table name itself, that would be alter statement, or that would be a DDL statement. Here we are talking about update statement, which is a DML statement. So if you want to change the column name, you need to use DDL statement. That we'll learn later in the course. Okay. So about updating the data within the table, any questions?
No.
So if we want to update multiple column in a table, so what to do? So update first table. Let's say I want to update the name and age of ID2. So where ID equals to 2, what are the things I need to change? I need to change the name. So name would be, let's say instead of Manoj, I want to update it to Sunil Anna. Okay, and age I want to update it to 36. Okay, so if we want to update multiple columns or multiple values of a row, we can do like this, separated by comma. So update first name, sorry, update first table where id equals to 2. So we can uniquely identify the row. And what are the things we want to update? Name as Sunil Anna and age is 36. So if I run this, one row affected, here it is. Okay. Now let's consider another situation. Let's say I want to change, um, let's say the age of Ravi to 24. Okay. So 24 where id equals to 1. Let's execute, updated. Now if you
And
can
if you
see age is 24. Okay, for both of them. Now let's say we want to update the age where age is 24. That means update first table where age is equals to 24. That will give us what? That will give us this row and this row, right? Let's say for this we want to change the age from 24 to 44, let's say. So first we are filtering with age 24. That will give us this row and this row. Once this row got selected or filtered with this where clause, we are going to update the age with 44. So this one would be 44 and this one would be 44. Now if I execute this, you will be seeing two rows affected, right? 44 and 44. So you can understand the sequence. First, this table would be selected, then the where clause would be executed. That will filter the rows, and then the update statement will execute. So first we are filtering with age 24, and once it is filtered, then we are performing the update with the same where on the same column of age. Is it clear?
yes, clear.
All right. So we already know about delete statement, right? So the syntax of delete statement is known to us. Delete from table name where condition, right? Let me show it one more time. Let's say I want to delete
I
all the values here where age is greater than 40, let's say. Okay. So before deleting, we can just simply select the rows where
Excuse me.
age is greater than 40. Yeah, tell me.
Yeah, suppose that if you want to update ID column,
Hmm.
then how can
Yes,
we
you can do
prefer
so.
that?
In the same way we have done it. So let's say you want to update the ID from 7 to 8. So update first table, set ID equals to 8, where ID equals to 7. So first the table would be selected, then the where clause would be executed. So it will filter out this row and it will update the ID column with 8. So if I run this query,
Oh,
one row affected. Now if I see this, 7 got updated to 8. So let's see
oh,
the delete statement. So let's say I want to delete all the rows where age is greater than 40. So I have performed the select operation to see what are the rows that are eligible for this deletion. So these two rows are eligible, right? Let's say greater than 35. Let's see. I can see 3 rows are eligible. So instead of select, we want to do the same thing. Instead of select, it would be delete, right? So it would be delete from table name where age is greater than 35. 3 rows affected. Now if I run the same query again, I can see all the respective rows are now deleted. So it's recommended that whenever you perform a delete operation, first use the where clause and run a select statement just to check that which rows are going to be deleted with this where clause. Because in the delete statement, where clause is very important, right? All right. So we have multiple where clause example that we have already seen. Okay, I'll put this in the class notes. You guys can practice. We have done order by clause as well, right? So let's understand about like operator. This is very interesting.
Hello, sir.
Yeah, tell me.
Can we undo delete command?
Yes, we can, but for that you need to learn one concept that is called as TCL, or transaction control language. So transaction control language you will be learning, I believe, after 1 class or 2 class.
TCL. Okay.
Yeah. All right. Here we have order table. So let's see, select star from orders. So this is my order table. So in this table, I want to see the order table details where order name, this is order name, where order name is starting with, let's say, K, or order name is starting with A, or anything, right? So what is the command? The command is, let's say you want to see all the order details where the name is starting with M, let's say. Okay, so this, if you don't know the exact value, okay, you don't know the exact value of this order name column, but you know that it will start with M or it will start with B, whatever it is, then you can use like clause. So select star from table name where column name, instead of equals to, you can use like. Okay, let's say it will start with M. Then what is this? Percentage. Percentage is telling SQL Server that I want to validate that order name is starting with M, and the rest part I don't care. Okay, I don't want to match anything for the rest part. I just want to match that the order name should start with M. So this symbol is indicating to bypass the validation of characters. The validation of characters would be only with this character, and the rest part would be bypassed. Okay, so if I run this query, so you can see all the order names starting with M is shown here. So it did not perform the validation of the entire value. It did the validation of only the first character, and the rest character was bypassed using this wildcard character. This is called as wildcard character. So it can consume anything, any character it can consume. The only comparison will work on this character. In the same way, if we want to see that where the order name will end with A, okay, so it will end with A. Last would be A. So in the front, whatever it is, we don't really care. Whatever is there in the beginning part, we don't care. We only care about the last character of the order name, sorry, the last character of the customer name. Okay, this is customer name. So the last character of customer name would be A. That is what we care. And what is there at the first, second, third, up to the second last, we don't care. So that is why we have put A at the end and we have put a wildcard before A. So if I run this, you can see all the customer name ending with A is shown, right? Now, let's say I want to see all the customer, all the order details where customer name is starting with M and ending with A, right? So must be starting with M, that is why the start character is A. Must be ending with A, that is why end character is A. So whatever there in the middle, we don't really care. So wildcard is coming in the middle. Okay. So starting with M, ending with A. We don't care about whatever is present in the middle. So if I run this, I'll get this value. Starting with A, starting with M, ending with A. Whatever in between EER, that is consumed by this character or wildcard. Now let's say you want to see the order details where customer name is containing a character A. Then what to do? If it contains the character A, that will show me the result. Just A.
So maybe both side percent.
Yeah.
Oh,
Doesn't matter
just
if
A.
it's coming in the beginning. It doesn't matter it's coming in the beginning, in the end, in the middle, whatever position. At least a character should be there in the customer name field. So how I can write this?
Then both side percentage maybe.
Yes. So both side percentage will do the trick. So whatever it is, I don't care till I get a character. And whatever there, I don't care till I get this character. So from front to end, if I get A, that is enough for me. From end to front, if I get A, that is enough for me. So this is the only validation I want. So if I run this, see all the customer name is holding the character A. Here we have A, 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 A. Let's check with E. See, all right. So this is about like operator. Is it clear?
Yes, sir.
Now let's move to our AdventureWorks database. Okay, and let's see what are the tables we are having. Let's say we are having sales.customer. So here we don't have much details. Salesperson. Let's check with person.person. So in this table we have many columns. So let's say I want to check the details of person where middle name is having J. So where middle name is J. So I can have all the values, right? So in the same way, I can see it's having many values. All right. Now let's consider I want to see the person details where first name is starting with Z. It's a very uncommon name structure, right? So let's say I want to see all the person details where first name starting with Z. So Z this like, that would be our command. Let's see. So I can see many person names where they are starting with the character Z, right? At the same time, I want to validate that their name is ending with E. So let's see. So I have this set of names. So this is how we can use like operator. So when we don't know the exact value and we want to, just figure out what are the details are there for any given set,
So let's
and
start.
we just want to see the, possibilities of data, then we can use like operator. All right, let's move on. This is again a very interesting topic. This is called as and or operator. So we need to understand this. When I say order ID equals to 2, when I say order ID equals to 2, what are the possible outcome this comparison can have? This comparison operator can have how many possible output?
2. Either it will be
2.
true or either it will be false.
Yes. So equals operator is basically a binary operator. Okay, right? Binary operator means either it can have true output or it can have false output, nothing else, right? So when I say order ID equals to 2, for all the other values, order ID equals to 1, order ID equals to, for order ID value 1, 3, 4, 5, 6, the output would be false. Only for the order ID 2, the output would be 2, because then it would be 2 equals to 2, right? Here it would be having 2, so 2 equals to 2 is true. All right, now here we have one thing to understand. When we have multiple conditions to check, all right, so let me tell you guys, when we open Flipkart or Amazon or whatever, we put filter, like filter. So what are the filters? Let's say price is less than 500. Also we put another clause like it should be fulfilled, right? Also we put another condition, let's say mm, it should be a particular brand, right? Another, we put another condition, let's say
Color.
it should be on a particular color, right? Whatever it is. So when we put these filters and we apply these filters, it shows us the output which validate what? Which validate all these conditions? Yes or no? So when we put all the conditions in Amazon filter or Flipkart filter, whatever, and after applying this filter, when we get the output, those outputs are validating all these filters. That means the output should uh, meet this condition and this condition and this condition and this condition. So it should meet this condition, also this condition, also this condition, also this condition. In other words, the output of this binary operator should be true, and the output of this operator should be true. The output of you know the output of this operator should be true, and the output of this operator would be true, right? Then only we are going to see the value. So whenever we are combining different binary operator with AND clause, that will give us the final output as true if all the binary operators are true. Is it clear?
Clear.
Yes, sir.
Yes.
So true and true will give us an output of true. True and false will give us an output of what?
False.
False. Because all the conditions must be true as we are combined these with AND operator. This should be true as well as this should be true. Then only the whole thing must be true. So true and true would be true. True and false would be false. False and true would be what?
False.
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 False and false and false would be what?
True. True.
True.
False.
False and false would be
False.
false. Because
Okay.
it should be true
Okay.
if both the conditions are true. If any of the condition is false, the output would be false. All right.
Both
That
conditions.
is about our AND operator. So this is I'm talking about AND operator,
Yes, we know about this or and.
right? So let's
Yes, sir.
understand about OR operator. OR operator is saying what? Either this condition is true or this condition is true. If any of the condition is true, it is enough for us to validate. So let me copy this thing. So it would be or, or. So this one will give us what? True or true?
True.
True. Because when we are combining two conditions with OR operator, then the entire condition will give us true if any one of this is true. That is enough to give the entire operator as true. So what would be the output of this? True or false?
True.
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 True. Why true? Because
Because
this one is true. Any one of the operator needs to be true, right? So this one is true. That is why we are getting true. What about this?
true.
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 And what about this?
False.
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 False. Because
False.
both of it is false, right? So this is called as AND and OR operator. Now let's see in the example. Let's say I want to see the order details where order ID is equals to 2 or order ID equals to 5. If I run this, I'll see 2 output. Now why? From this output, so it will show the output if this condition is true or this condition is true, right? So let's take for the first row, order ID 2. So this one is true or false. For this
True.
row, order ID equals to
True.
2, right? So it is running this condition, true, order ID equals to 2. So 2 equals to 2, true or false? True. 2
True.
equals to
True.
5, true or false? 2 equals to 5, 2 equals to 5. It's true or false?
True. False. True.
False.
2 equals to
False.
5 is false, right? So we are getting true or false. So true or false will give us the output as
True.
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 So for the order ID 2, we are getting as a whole condition, we are getting the true output, right? So this row is showing.
Yes.
Let's consider the next row, order ID 5. 5 equals to 2, true or false?
False.
False.
False. 5 equals to 5, true or false?
True.
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 So false or true? False or true? It will give us
True.
what? True. So as a
True.
whole, for order ID 5, we are getting true. That is why 5 is getting shown here. Now let's consider about 1, order ID 1. 1 equals to 2, true or false?
False.
1 equals to 5, true or false?
False.
False.
So false and false will give us false. That is why order
False.
ID 1 did not appear, right? And the same thing goes for the other row as well. All right. So this is how the OR operator works. Now let's say I want to filter. Let's say I want to filter where name equals to customer name equals to Debu, and let's say no. Let's say I want to check for the order name Momo and the quantity as 2 or the quantity as 4, right? So what I need to write, select start from dot orders. So I want to see order name as Momo and quantity as 4. I want to apply
Where
both the filters. So what query we need
order
to write?
name. Where order name
Order name,
equals to
order name equals to Momo, then
and
and quantity is equals to 4,
24.
right? So as I combine this thing with and, so both the conditions needs to be true. Then only it will show the
True.
output, right? So is this clear?
Yes.
Now in the same way, let's run this query. In this query, I want to see quantity equals to 1 and recommendation is not null. So that means there is some recommendation and quantity is 1, both in AND clause, right? So that is why we have seen these two records. Now if I run the same condition with OR clause, it will give us this. So if I run both the query, you can understand the difference. See, 3 and 5 is present in the first query with AND clause. 3 and 5 is present in the second query with where clause. Why? Can anyone tell me? With AND, we have 3 and 5. With OR,
And 5.
we also have 3 and 5. because and is showing the output where both the conditions are true. So this is also true for OR operator, right?
Mm.
AND operator, it will show the
Yes.
output if both the conditions are true. For
Okay.
OR
Two.
operator also, it will show the output if both the conditions are true. That is
Two.
why we have 3 and 5 in both AND and OR output. But additionally, with OR operator, we have some other flexibilities as well. So true false will show us the output, false true will also show us the output. That is why you can see the conditions are quantity 1 recommendation not null. So you can see quantity 4 recommendation not null. So this one is true, that is why shown. Condition quantity 2 recommendation not null. This condition is shown. Condition quantity 1 recommendation not null. So shown. So we don't have any situation where recommendation is null. Let's see if we have anything where recommendation is null or not. Yes, we have it, but for the quantity of 2. If I run it for 2, then we can get the data. So this one, you can see quantity is 2, true. Recommendation not null, false. But still it's showing because it's falling under OR operator. So that is how the AND and OR operator works. And we can combine multiple conditions using AND and OR operator. Is it clear to everyone?
Yeah. Yes, sir.
Yes.
Mm, so let's learn about the next thing, which is called as in clause. So this is in clause. Let's say I want to see order details where ordered ID is 1, 2, 3, 4, right? Sorry. So I can use in clause. So order ID instead of equals to, I'm comparing it with a set. So when we are comparing with a set, then instead of equals to, we'll be using in. So if I run this, all 1, 2, 3, 4 will be shown. Now one may ask me that instead of this, we could have used order ID less than 5. That will also show us the same output, right? But we are not sure that we want sequential values or not. Let's say I want uh, 8, 4, and 1, only these 3 values. Then what is the option? We don't have any other option instead of using 8, 3, and 1, right? So instead of doing multiple checks, we can do it in a single check using in operator. Is it clear?
Yes, sir.
Yes, clear, I
So
think.
let's say we want to see the order table details where ordered ID equals to 8 and 3 and 1, right? So instead of checking order ID equals to 8 in a separate query, checking order ID equals to 3 in a separate query, checking order ID equals to 1, instead of doing all this headache, we are simply running this query order ID in 831. This will show us these details. Now my question to you guys, can we implement this query without using in clause? Can we do this with and or operator?
Yes, sir.
So can someone
Yes,
write
with
the query and ping in the chat? Please write the query and ping in the chat. Let's see.
Devabrata, I don't think it's possible because we are giving a specific criteria, right? With and or, I'm not sure how it will work.
So you are saying it's not possible. Okay, someone else is saying it is possible. Let's see what are their
Okay,
solutions.
sure.
So here we are doing checks, right? We are doing check. Order ID could be 8,
Hmm.
order ID could be 3, order ID could be 1, right? So basically we are doing 3 checks in this. So can you combine 3 checks using AND or operator?
Yes, three we can do, but when it is like more, in that case, it would be a little difficult.
Now let's consider this example. So can you convert this query
Hmm.
can you write this query in any other way?
Yes, sir, by using OR operator, we can.
Please write down the query and ping in the chat.
Actually, sir, I don't have a sufficient
Sir,
data
I
in
have
the
written,
table, sir.
please check.
That's why I'm.
Mm,
See, and or we need two things to compare. Um, no,
So I'm
I give up.
taking the example from Aryan, okay?
Okay,
Because Aryan has written the query correctly.
okay.
Sorry. So what it's writing here is, so the table name is dbo.orders. That's the only mistake he has made. So select star from dbo.orders where order ID equals to 3 or order ID equals to 8 or order ID equals to 1. All right. So this is how we can write this. If you see the query, they are giving the same output.
Debabrata, can we do this with and also? Order ID 8 and 3 and
If we
1.
do it and, so is it possible that order ID would be 3 as well as 8 as well as 1 for any one row? No, right? Because
Okay.
order ID is unique. One order ID cannot be 3, 8 and 1 at the same time.
Yeah.
Yes.
So is it clear to everyone about in
Yeah.
Yes,
operator
sir.
and this example?
So we can say in operator is a combined of multiple OR functions, kind of.
Yes. So a in operator is basically a better implementation of these operators. Okay.
Okay,
But
got
what
it.
is the limitation? The limitation is in operator will only work if it's dealing with on the same column. But in the OR operator, we can combine the clauses with different columns. Let's say order ID equals to 3 and amount equals to 120. So we are working
Okay,
with different
Okay,
columns
yes, sir.
with OR, right? But for in, it has to be on a particular column only.
okay,
Yes, sir.
got it.
All right. Next one. Mm, distinct operator. Right, let's move to AdventureWorks database. So we have a table called person.address. So in this table, we have all the details of persons, right? So here we have a column called city. So let's say I want to see the city details only. So if I run this, I'm getting total 19,614 row of city, where we have multiple repetitions, right? Paris, Paris, Lille, Lille, right? So if I want to see the distinct city, no repetitions, right? I don't want to see any duplicate city. I just want to see the unique city. Then the filtration of uniqueness can be done using this command, distinct. Like after select and before the column name, we need to give this command, distinct. So if we run this command, it will show us the distinct city which is present. So the distinct city count is 575. So here you can see all the city is present, but there are no repetitions. Okay. So to get the distinct value, we need to give distinct command. Okay. So let's take another example. Uh, let's say you want to see the distinct state province ID. So select distinct state province ID from person.address. If I run this, I'll get the distinct state province ID. So we have total 74 distinct state province ID. So this is how a distinct operator will work. So it will give you the unique value of a particular column. Is it clear?
So this is just like removing duplicates in Excel, right? Kind of.
Yes. So let's say I have a table, and in this table I have many values for a column, right? I was having a good example actually. Let me see for that example. Yes, this is the example. All right. So I have a table called person. Now, if someone tell you that tell me the uh, blood group details, tell me the available blood groups in the population, then what would be the query? The query would be
Select distinct
Select.
blood
blood group.
select blood group from person,
Hmm.
right? Now, if I run this, I'll be getting a lot of blood group with
Yeah.
repetitions, right? Now, if I don't want to see the repetitions, my target is just to see the available blood groups. I don't want to see the repetitions. So I'll use
Like distinct blood group.
distinct blood group from person. It will eliminate all the duplicate value and it will show me the distinct blood group. Now, in this output, I can see there is one null. If I want to eliminate this null, what I need to do?
Is not null.
We have to use clause.
Where blood group is not
Where
null.
blood
There
group
clause.
is not null, right? So if I run this, I can see the unique blood group that is available in the population. So is it clear to everyone? I hope it's clear, right?
Yeah.
All right. So next one is alter table. So before we go for the alter table command, let me give you guys one task.
Please go on mute.
So this is the requirement. This is the question. So please write down the query. This is the table structure. This is the question. Please write down the query and tell me once it's done and ping in the chat. I'll take the query and I'll see the result. Okay. So I'll give you guys 2 minutes. I'll be on mute for 2 minutes. Please paste your result in the chat. All right. So I can see only Aryan has posted till now. Anyone else? All right. Let's take the example or the solution from Aryan. So the question is show unique city name. So distinct city where address line 2 is not null. Address line 2 is not null. And postal code starting with K. Postal code like K percentage in descending order. So he missed to put the descending order or order by clause, right? So if I run this, it will give me the output, but we need to give. So let's say, let's give something else where I can get multiple values. Let's say K, H. We are getting only one. Let's say ending with, let's say J. We are getting only one values. It's not what we want. Let's say starting with 9. Okay, let's see. Yes, we are getting multiple cities. Starting with 9. 9 is having multiple cities. Starting with 8. Let's see. Yes. So this is a smaller set, easier to understand. So I want to see the distinct city where address line 2 is not null and postal code is starting with 8. And I want to represent it in descending order. So here I need to put another clause which is ordered by city,
Order by city December. December.
right? If I execute this in descending order. So let's say this is the query for this requirement. Is it clear to you guys? So starting with, it would be 8. Is this query clear to everyone with respect to this problem statement?
Yes, sir.
Yes. Yes.
Let's see about alter statement. So let's create a table. Student. This is my student table. So here student name is varchar 64. Now we come to a situation, or we come to a requirement. There is a change in requirement. Now we can see that the length 64 is not sufficient to hold the student name. Okay, we need to increase the length. So if we need to change the data type of a particular column where the table is already existing, right? So the way to do it is alter table. Alter table is a DDL command or data definition language. So we learned about create table, we learned about drop table. Now we are learning about alter table. Okay. So if we want to change the table structure, then we need to use alter table command. So the syntax is alter table, table name, alter column. So within this table, I want to alter a column, right? Alter column, the column name I want to alter, and the new data type and the new column type. So if I run this and I see this, let's refresh the column. See the character, the data type got updated to 128. It was initially 64 and now we updated it to data type varchar 128. So in the same way, let's say we come into a requirement where we need to add a new column. So there was no column called address, and now we want to add a column called address with this existing table. How to do that? Alter table, table name. Previously it was alter column because I want to change or I want to alter a existing column. Now I want to add a column. That is when we need to use add command. So alter table, table name, add the column name we want to insert, the data type of the column, the column type of the column. I run this command, a new column address would be added at the very end of the table. Now let's say I want
Mhm.
to drop a column called age. To do that, we have alter table, table name, drop column, column name. Now if I run this, the age column would be dropped,
Debabrata, I
right?
have a question.
Yeah, please tell me.
How do we get to know that what length we should be given to this data type like varchar?
Okay. So what length, right?
Yeah.
So that based on the requirement, because let's say um, you are creating a table for your restaurant menu. Okay,
Mm-hmm.
so in the menu table you have ID, you have name, you have price. Okay, so ID of that particular dish, name of that particular dish, and price of that particular dish. So ID you did as int, name you given this as varchar,
Varchar.
let's say 4, or let's say varchar 12. Okay, and price is also int, let's say.
It.
Now in the first month, whatever dish you have, the name is within 12 length, right? Now suddenly you are coming up, or you are adding something in your menu
Yeah.
where the length is more than 12. So
Okay.
you are unable to store it within this menu table. So that is when you realize that the length must be something bigger than 12, as your
Mm.
dish name is, the name of your dish is, let's say, something like this. The length is
Okay.
more than 12. So here the data type should be more than 12. So that is when you realize that it should be 32, right? And that is when
Okay.
you need to alter the table, right?
Correct.
So is it clear about altered table statement?
Yes, sir.
All right.
Devabrita, how can you have added that address column, right? So only to that alone column, how can we add multiple values?
Multiple values.
Yes.
Sorry, I didn't get
I
that.
mean, how can we insert that data into only to the address?
No, we cannot insert only to the address. So let me give you the example. Let's say select star from student. So you are saying we have some already existing values in the other columns, but address is newly added. So how we can populate only the address column, right?
Exactly. Yeah.
So you need to run a loop. You need to run a while loop, okay, on this ID column. So that is a complex query you need to write. You can write this query once you learn about different clauses like if else clause, while loop, different temporary variables, temporary table. Only then you'll be able to write that query. So this kind of query is called as data population query. Okay, so data population query we need to write, but for that you need to learn some more commands to be able to write this kind of query. By the end of the course, you will be able to write. Okay.
Yeah. Okay. Thank you.
Now here we have a very important topic which is called as index. Very interesting topic. So what is index? So let me ask you one question. What is the main purpose of a database? So
To
previously
store.
also we used to save data in physical books, right? Physical copies, writing down data in the physical books or physical notepads, right? So why
Yes.
we moved to database? Because we want efficient way to write information. We want efficient way to read information. We want efficient way to update information, right? So efficiency is very important. So when we talk about index, index is all about improving the reading efficiency. Okay. So improving the searching performance when we talk about index. So let's talk about a book, and the book is having 1,000 pages. Okay. If I tell you that please search a topic XYZ, so what will be your way to search the topic XYZ in that book having 1,000 pages? Can anyone tell me what would be the procedure?
Yeah, we go to the index,
Hmm. So in a book
and
we
there
have
we
we have in a book we have index pages at the very beginning, right? In the index pages, what we have? Topic name and
page number.
the respective
Page number.
pages, right? So when I say please go to the topic XYZ, I'm not going to search the book from page 1 to page 1000 to search the topic XYZ. I'll open the index of the book, and the index is what? That is present at the very beginning of the book, right? Like 5 or 10 pages where we have chapter, then within chapter we have some topic, subtopic, right? And then we have the respective pages where we can find the chapter for that particular topic. Also we have page number, right? For subtopic also we have page number, and so on. Now if I tell you to search XYZ, I'll go to the index pages. Let's say we have total 5 index pages in that. I'll search in the index page, so I'll not search in the book, right? So this is one way of searching. Is it clear? Is this understanding clear to everyone?
Yes, sir.
Yes, yes.
Yes.
All right. Now let's talk about dictionary. Let's say we have a dictionary of 2000 pages. I told you to find a word where the word is what would be the way to search the word yeti in the dictionary?
So we have
So
to
one thing to
open
understand,
first letter.
dictionary does not have any index page. So do you see any index page in dictionary?
No,
Starting
sir.
from
No.
No,
page
sir.
1, it will start with the words, right? So no index
Yeah,
in
it will be
dictionary.
in ascending orders.
So how you are going to search a particular word in a dictionary?
We have to search with the letter, sorry, alphabet Y
We
first.
start with Y.
Starting with
Will
Y, then after we will go sequentially.
Yeah.
Then
so
E comes and
Y,
J and I.
E.
so the thing is, we have an agreement how the data is stored in the dictionary. Agreement on data storing mechanism, right? What is the agreement? We know that the data is sorted in ascending order. Yes or no? We know that within the dictionary, the data is sorted in ascending order, right?
Yeah.
So we'll start searching accordingly. So the search mechanism will also be performed in the same manner, search on agreed manner. So this search mechanism depends on how the data is stored within the dictionary. Yes or no?
Yes.
So in the same way, in table we have two type of searching mechanisms. Okay, one mechanism is called as normal book type, one mechanism is called as dictionary type. So this dictionary type searching mechanism called as clustered index. This normal book type searching mechanism is called as non-clustered index, right? So let's go to the definition. Clustered index: physically sorted data on a column in a particular order, same as dictionary. So in dictionary, what we have, we arrange our data in a physically sorted manner, right? Clustered index also maintain the same thing. It physically arrange the table data in a particular manner so that when you want to search for a particular record, you know that how the data is sorted physically, so that you can search the data accordingly. Okay. Now in non-clustered index, we have some dedicated index pages. On top of our actual data pages, we have some dedicated index pages. Okay. So the dedicated index pages for a table like normal book. And whenever we search for a data, we search it in the index page, then only we navigate to that particular data page. Is it clear? Is it clear to everyone?
Yeah.
Yes, sir.
And when we don't have any index on a table, then it is called as heap table. Heap table means no index on a table. That is called as heap table. Okay. Now let's see visually how an index looks. Right. Mm, Let me first go through the non-clustered index. That is more easier. So this one. So here, this is our actual data pages and this is our index pages. Okay. So as you can see, the index page is there, and along with the index topic, we have a pointer, which is actually pointing us to the actual data or actual information. Okay. So we are going to search only within the index page. Let's say I want to search for 6. So I'll go to the index page searching. I'll reach to 6, and from 6, it will navigate me to the actual data page. And there I'll get all the information. This is how non-clustered index work. Is it clear? And when we
Yes, sir.
talk about clustered index, that means there won't be any index pages. The entire data would be sorted in a particular order. Okay. Now let's see about this example. So here we have roll number. This is index page. Okay. So in the index page, we have the index key, which is roll number, and we have a particular page or pointer where we can find the data. Let's say you want to search for roll number 1. So roll number 1 you'll get in page number 10. So where is page number 10? This is page number 10. So you'll point to here. So under this, you'll be getting your information. For roll number 1, you are getting the respective information. Let's say you want to get roll number 7. So how you can get 1, 5. So here we have 5. and 9. So I'll follow the page number of 5. Why I'll follow page number 5? That I'm coming just in a moment. For now, please consider this. So page number 5, I'll go to roll number 5, I'll go to page number 11. So this is page number 11. I'll come here. Here I can see roll number 7 is present in that page. So here I can see all the details of roll number 7. So this is how, using the index page, I can find the actual data. So when I'm searching for roll number 7, so I'm skipping searching this page and this page. I'm directly going to this page, right? So here the number of roll number is 1 to 12. So I am supposed to search for 12 times to get my data, right? So if I want to search for 12, roll number 12, I supposed to search from roll number 1 to 12. Then only I'll be getting roll number 12 details, right? But instead, what I'm doing is I'm searching in the index page, and from the index page, I'm navigating to this page. So I'm searching 1, 2, 3, 4. Only 4 times I'm searching and getting my data. I'm skipping the 8 time search operation here. This is how the search operation works. Now, how we are doing the search operation, or how the index is actually stored. The data structure of an index is B plus tree. Okay. Now, what is B plus tree? Now, when I talk about searching within this, then this type of searching happens on B plus tree data structure. So what is B plus tree data structure? So this is how a B plus tree data structure looks. Okay. So what is B plus tree? So it is this is not a very good example. Okay, anyway, let's take this example. So it's containing with root node, leaf node, and intermediate node. Okay, and the idea is we'll start searching from top and left. So we'll travel from top to bottom and left to right. Okay, we'll travel from top to bottom and left to right. Okay, so let's say I want to search for 8, or let's say I want to search for 7. Okay, let's say I want to search for 8. Let's consider this. Okay, so the mechanism is, when I'm searching, so I'll start searching from root node. I want to search 8, and in the root node the value is 7. So 8 is greater than 7. If it's greater than, I'll go right. If it's less than, I'll go left. Okay, so I want to search 8 starting with root node. So 8 is greater than 7, so I'll go right here. Now here I got 9. So 8 is greater than 9 or less than 9? Less than 9. So I'll go left. Left I'll start with here. So 8 is greater than 7. I'll go right. 8 is equals to 8. So I got my information from how many search? 1, 2, 3, 4. After 4 search, I got my data. And the total data I'm having in the table is 16. So give me a number. Let's say you want to search 15, right? So how we can search for 15? Coming from root node. 15 is greater than 7, going right. 15 is greater than 9, going right. 15 is greater than 11, going right. 15 is greater than 13, going right. 15 is greater than 13, going right. 15 is greater than 14, going right. 15 is equals to 14. Sorry, 15 is equals to 15. Then I get my data. So 1, 2, 3, 4, 5, 6, 7. I searched for 7 times and the entire data set is 16, right? So less than half I need to search. So let's say you want to search for 6. How you can search? 6 is less than 7, going left. 6 is greater than 3, going right. 6 is greater than 5, going right. 6 is greater than 5, going right. 6 is greater than 6. So here we get the data.
And Debabrata, who decides this loop node?
So this root node and leaf node is determined by the B plus tree algorithm. So how to create a B plus tree? That would be determined the B plus tree creation algorithm. So that's an entire different topic, how to create a B plus tree. Okay, you guys can go through that
Mhm.
topic to how to create a B plus tree, but that would be a different topic altogether. So I don't want to get into that. You guys can have a look. I think I have put the topic in the homework. Let me see. Yes, what is B tree, what is B plus tree, and how to create B plus tree. You guys can have a look. But I mean, you guys never going to use the algorithm because the algorithm is used by SQL Server itself. Okay, but
Mhm.
you guys need to know the algorithm, or you guys need to know how the index is stored in the background. Okay, now let's have some understanding now. Okay, now we understand that if we have index, our search operation would be fast, right? Yes or no? If we have an
Yes.
index on a table, our search operation would be fast. What are the disadvantages? First, search operation. Now let's consider about I have a cluster index on a table. Okay, let's consider about I have a clustered index on a table. So I'll be having first fast search operation. But if I perform an insert operation, what are the consequences? Let's say I have record 1, 2, 3, 4, 5, 6, 7, 8, 9, right? These are the records of my table. And my search operation is very fast because I have sorted it in a particular order. So I can search my data very quickly. So let's say suddenly I am trying to insert a value 4.5. So what would be the impact on my table or on my index? So 4.5 will insert in which position? Between 4 and 5 to maintain the order. So
Yes.
I need to move these many records to create a space between 4 and 5. Or in other words, I can add 4 and 4.5 at the end, and then I need to rearrange my data. I need to rearrange my data to maintain the cluster index, right? I need to rearrange my data. Unless the cluster index won't be maintained, yes or no?
Yes.
So for cluster index, search operation is fast, but insert operation is slow. Clear? Is it clear to everyone?
Yes, sir.
So for a heap table, there we don't have any index. We'll be having slow search operation, but faster insert operation. Why? Because in a heap table, we don't maintain any order, or we don't have any index pages. So searching a value means searching all the records, right? If we don't have any index, or in other words, in a heap table. But if we perform an insert operation on a heap table, we don't have to maintain the index, we can simply go ahead and insert the record in any position we want. Wherever we find the available space, we can insert the data. We don't have to maintain our index for heap table, right? Yes or no?
Yes.
So heap table would be effective for insert operation and non-effective for search operation. And for index, search operation would be fast and insert operation would be slow. All right. So that's about it. Now we have some naming convention. So one thing to understand, whenever we create a primary key on a table, automatically there will be a clustered index created on a table. Okay. So that is a default phenomena of SQL Server. Whenever we create a primary key on a table, there will be a clustered index created on the table automatically. Okay. So when we create a clustered index, the clustered index naming convention is something like this. It's not mandatory, but in industry, we generally maintain this naming convention. Like for primary key, we maintain this naming convention. So for primary key, it should start with pk underscore table name underscore column name. That will be maintained for primary key naming convention. pk means it's a primary key. On this table, on this column, we have created the primary key. So that is how we create a primary key name. In the same way, when we create a clustered index, then we'll start with CL for clustered index, the table name, on which table we are creating the clustered index, on which column we are creating the clustered index. For non-clustered index, the naming convention is IX, table name and column name. Now, very important question in interview perspective. How many clustered index we can create on a table? How many non-clustered index we can create on a table? So the number is, clustered index we can create only one on a table. Non-clustered index we can create 999 on a table. Now the question is, the interviewer will ask you how many clustered index we can create on a table. Your answer would be 1. Then the next question would be why. Why we can create only one clustered index? Can anyone tell me
Be-
why we can create only one clustered index?
Primary.
One primary key.
One unique ID, one column which has all the unique IDs.
No, we have only one primary key. Just
Yes, only one primary key, I think so.
Sorry guys, I was on a call. Yeah, please tell me why we can create
We
only
have
one
only one
clustered
prime
index on a table.
because we have only one primary key,
No, not exactly. Anyone else?
unique ID.
Because that's a single, only one column with the unique IDs, right? That's why maybe.
No. Okay, let me ask you how a clustered index is created on storage level. On storage level, how a clustered index is created. A clustered index means we are sorting our data in a particular order, right? So let's say
Yeah.
my data is 1 to 9. If I tell you to create a clustered index on this data, you'll be sorting the data into 1 to 9. Can you arrange this data in any other way? Let's say
Man,
if I tell you to create another index, another clustered index, that means you need to sort the data in this order. Is it possible to sort this data in any other way than this?
Descending order.
It
No.
means we have to use sequence.
So cluster index means physically arranging the data in a particular order. So can you physically arrange a data in a particular order in more than one way?
No.
No.
No, sir.
If I tell you to arrange 1 to 9 in a particular order, you can arrange in only one possible way, right? So if I tell you to create a dictionary of 1,000 words, you can create only one dictionary, right? So the dictionary will be exactly the same. So let's say here we have 10 students. Let's say for every student I have given the same 1,000 words, and I tell you guys that please arrange the words uh, in ascending order. So is it possible to get any other solution than one?
No.
No.
So there will be only one outcome, right? So
Right.
clustered index is also the same thing. We are physically sorting the data in a particular order. That is why we can have only one clustered index. Now let's come to non-clustered index. Non-clustered index means there is no hard and fast rule of any particular order. It's all about having a dedicated index page. So let's say I have given you guys a book of 1,000 pages, okay, and I told each and everyone that please create an index of 5 pages. So let's say I have given 10 of you guys to give me a solution. So 10 of you guys will be giving me 10 of different index pages, where topic 1 would be at the beginning, topic 10 would be at the end. Someone may give topic 5 at the beginning, topic 4 at the end, whatever, depending on their uh, understanding, depending on their uh, assumptions, right? So we are going to end up with multiple or different type of index pages. That is what happened for non-clustered index. But for clustered index, we can have only one possible option, or we can have only one possible way to sort our data in a particular order. That is why we can have only one clustered index, and this number 999, this number is set by Microsoft. There is no logical reason that why this number. So it could be 99, it could be 100 or whatever, but the number is set by Microsoft as a maximum limit. So in simple words, we can have multiple non-clustered index, but we can have only one clustered index. Is it clear to everyone?
Yes, clear.
Yes, sir.
So let's see how we can create primary key on a table, and that will lead us creating the index automatically. Okay, let's create a table test 1, column 1, column 2. Now after creating a table, if we want to create the primary key on top of table, then the syntax is alter table name, add constraint. This is my primary key name, pk underscore table name underscore column name. Okay, this is a primary key on column 1. So if I run this, then column 1 would be primary key. Sorry, test 1. Okay, so let's see the table. This is my table. So whenever we create a primary key, automatically a clustered index would be created. All right, is it clear, guys? Now if we want to drop the primary key, the syntax is alter table table name drop constraint my primary key name. If I run this, see, the primary key got dropped. So whenever the primary key got dropped, the index will also get dropped. So primary key is directly linked with cluster index. Okay. Now let's see how we can create a non-clustered index, or how we can create clustered index without having a primary key. Okay. Mm, so create clustered index, index name on table name, and here is my column name. So if I run this, what is the syntax? Create clustered index, my clustered index name. So this thing is optional. You can remove this thing as well. Okay. So this is my table, test one. Here is the column. Here is the index. No index, no primary key. And the columns are column 1, column 2. Now I am showing you this because just to show you guys, even if we don't create primary key on the table, we can create cluster index without creating primary key. Okay. So if I create primary key, by default a cluster index would be created. But if we don't create primary key on a table, then also we can separately create a clustered index. So the syntax is create clustered index. This is my clustered index name. CL means clustered. Test1 is my table name. Column 1 is my column name. So I'm creating this clustered index on this table, and I'm creating the clustered index on column 1 in ascending order. Now as I discussed that what is clustered index? Physically sorted data on a column in a particular order, right? So on a column in a particular order. All right. So create clustered index, index name on table name. Here we have column name with that order. So let's create, done. Let's refresh the table. So under column you can see no primary key created, but under indexes you can see that cluster index has been created. In the same way, we can create non-clustered index. Create non-clustered index ix test1 is my table name, column name is column 2 on test1 table, and this is column 2. So let's create it, non-clustered index. If I refresh the index folder, the non-clustered index got created. In the same way, we can drop our index. Let's drop this non-clustered index. Drop index, index name on table name. But on this, my non-clustered index will be dropped. If I want to drop my clustered index, I can also drop my clustered index. Right? Now let's go ahead and try to create the cluster index one more time. Now one cluster index got created, right? Now let's try to create another clustered index. I got an error. cannot create more than one cluster index on table test1. Okay, as I said, we cannot create more than one clustered index. So let's create a non-clustered index on the table. So non-clustered index created. Now let's try to create another non-clustered index. The not clustered index got created. Let's try to create another non-clustered index on the table. Another non-clustered index got created. So we can have multiple non-clustered index, but we can have only one clustered index. Is it clear to everyone?
It's clear, but
Guys, is it clear?
you haven't changed that non-cluster index column 4 on SD on DOB test 1 and thereafter column 1 ascending, column 2 ascending. Why?
I'm creating the non-clustered index on the same column. That's not the point.
Okay,
The point
okay,
is
okay.
we can create multiple non-clustered index, but we can create only one clustered index. So I told you
Okay.
guys, and I want to prove you this. That is why. Okay. All right. So, so creation of clustered index, non-clustered index is done. So that is it for today. There are some examples. Okay. So these examples you can practice. These examples I already shown to you guys. Okay. You can again practice these examples. What is the maximum index then can be created on a table? Clustered is 1, non-clustered is 999. Why is this? That I explained. And as a homework, here we have what is index, what is clustered index and non-clustered index, and heap table. What is B plus tree and how to search data in B plus tree. So it will be B plus tree. And task for you guys is creating primary key after the creation of a table. Another task would be, okay, so let me paste this homework. All right, so before we wrap up, any questions, any doubts?
Yes, Devrita, I do have a question. Actually,
Yeah,
when there's some change in setting, I guess when you were explaining things, I was doing same at my laptop, and my select function is not working properly. Can I share the screen, please?
yeah, sure. Making a presenter, please share your screen.
So here, when I'm typing something, it is not getting it's not getting spaced. So it's getting less space, so I'm unable to type properly.
I think you have clicked the insert button. Can you please double another one more time click on insert button? Insert key. We have a insert button in the keypad. So can you click on insert button?
Okay,
Yes.
okay, understood. Yeah. Thank you so much.
Deepavita, can you just post that commands on the chat box, please? Clustered and the non-clustered wala.
Clustered and non-clustered.
Yeah.
Uh, let me paste the table creation as well. All right. Anyone else? Any questions?
I have a doubt. See, when we use the update function, if we
Mhm.
use it on a primary key like a student ID, like if you have
Update,
one
not update function, update command. Yeah, go ahead.
update command, so if we use it on a function like if I want to change the number 4 to 6, and there is a number already present like 6, so will it update or will it show error? How will it be?
So you need to use primary key. So let's say the ID is 4 and you want to update it to 6, but you
Yeah,
already
but
have a
6 is
ID
already
called
present.
6.
But 6 is already
Then
present there.
you'll be getting a primary key violation, the data duplication. You cannot update it to 6. You can only update it
Okay.
to 6 if you don't have any value of 6. If you are
Okay.
updating the primary key.
Okay. Got it. Got it.
All right. Anyone else? Shreyash? Shreyash raised his hand. Tell me, Shreyash.
No, it was on by accident. Sorry.
Amol. Amol, I can see raised his hand. Amol, you there? Yeah. Any questions, Amol?
No, sorry, it was by mistake.
All right. So, thank you, everyone. I'll post the class note. You guys can get the class note from Sanchita. She'll be uploading it, and we'll be catching up. I'll be taking the next class on Monday. Okay. Thanks, everyone.
And
Have a
we
good night.
don't, and we haven't got that PPT you have told that you will give us to.
Yeah, we'll be providing the PPT. Don't worry. I'll tell Sanchita to upload the PPT. Okay.
Yeah.
Anyway, you'll be getting those PPTs. No worry. Okay. Thanks,
Thank you.
everyone. Good night.
Thank you, sir. Bye.
Thank you.
Thank
Take
you,
care.
sir.
Good night.